Okay, let's unpack this. Today, we're taking a deep dive into, well, what might seem like two completely different worlds.
Yeah, on one hand, you've got the precise, abstract world of mathematics, calculus specifically.
And on the other, the, boots on the ground reality of managing forests, real world stuff.
Exactly. Our source material today comes from an excerpt discussing a math podcast, actually.
Right, and it's exploring how these advanced mathematical concepts pop up in really practical fields.
And the specific intersection highlighted here is mathematical integration, how it's used in forest resources technology.
Forest resources technology. So think about foresters, right? They need to measure land.
Sounds simple enough.
But it's not. You think about these plots of land, they aren't neat squares on a map, usually.
No, not at all. They twist, they follow like natural contours, maybe bounded by a stream or an old fence line.
Yeah, inherently irregular shapes. So our mission for this deep dive, based on what the source is focusing on, is to understand
How the calculus concept of integration is actually used to measure the area of these, well, messy, real-world forest plots.
and also why this specific example is being talked about for college students who are learning this math. Why pick this application?
Well, it's a fantastic example of abstract math meeting a very concrete problem, isn't it?
Totally. Measuring a perfect rectangle or triangle. That's easy, basic geometry.
Right, stuff you learn early on.
Uh-huh.
But nature, especially in a forest, it rarely gives you those perfect straight lines or simple curves over large areas.
You can't just multiply length by width if the boundary is, say, a winding river or some uneven property line marked by old stones.
Definitely not accurately, anyway.
Okay, so this is where it gets really interesting and where integration comes in.
Mm-hmm.
The source material really points out that integration gives you the precise mathematical framework you need for these irregular boundaries.
It does. If you picture integration, what you're essentially doing is summing up an infinite number of tiny, tiny slices, infinitesimally small pieces.
To find the total area inside a boundary. Even if that boundary is complex, wiggly, not a straight line.
Precisely. So the challenge then becomes, how do you actually represent that forest boundary using math?
Right, it's not just sketching a curve on paper.
No, you're using real-world data. Things like surveying techniques, GPS coordinates gathered along the perimeter.
Even aerial mapping data.
Sure, that can generate data points describing the edge of the plot. And integration lets you take that data.
All those points.
Yes, basically define the boundary shape numerically or maybe fit a mathematical function through those points.
And then calculate the area inside that shape.
Exactly. With a level of precision that, basic geometry just can't offer for these complex shapes.
So, okay, what does this mean for you, the listener, if you're maybe wrestling with differentiation and integration in a math class right now?
Well, this deep dive into the source really shows that these aren't just like abstract drills in a textbook.
They're vital tools. They have direct applications in fields like environmental science, natural resource management.
And forest resources technology, as we're seeing.
Yeah, the source highlights this specific application, it seems, to make integration feel more engaging,
Yeah,
relevant.
absolutely. To show students a powerful why behind the what they're learning. It's a tangible link between theory and, well, a job someone actually does.
It goes beyond the typical textbook problem, like finding the area under a simple curve, a parabola, or something.
Right. This is about measuring valuable natural resources on the
Right.
ground. And that accuracy, it's critical in forestry.
Why is it so critical?
Well, think about calculating timber volume for harvest. That affects revenue, sustainability plans,
Okay.
or defining conservation zones accurately, managing water runoff,
Yeah.
even just assessing land value for sales.
An error in the area could really mess things up.
It could have significant ecological and economic consequences. Integration provides that necessary mathematical rigor when just approximating isn't good enough.
So this deep dive, it really just underscores the, I guess, elegant power of integration.
Taking a core calculus concept and using it to measure the complex, messy reality of nature, like these forest plots.
Turning real-world data into crucial information, it's pretty cool.
It is. And that kind of brings us to a final thought for you to chew on.
Okay.
Consider how many other seemingly abstract math concepts or formulas you might be learning right now. They could have really surprising, essential applications in fields you just never expect.
Like what other real-world problems, maybe far from a standard math class, could integration or maybe other advanced math be quietly solving right now?
Exactly. Something to think about.